Okay, ask your friends to join. I'll be continuing. Ask your friends to join. Dhruti, Mekala, Raghav, ask your friends to join. They may feel that it is a 3 o'clock. You convey the message starts at 2:50. Shall I start? Shall I start?
Yes, sir.
Okay. Should I wait for another 2 minutes?
We'll wait, sir.
Okay, I'll continue. See, the load, what was were talking, it's minus 40. Minus 40 in the sense the load has to be like this, right? Minus 40. This is beam, this is the beam length, this is minus 40. Below the beam axis the load is acting. This is minus 40, this is downward. Therefore, if I consider same convention what we took for shear force, minus 40, this is like this is like this, minus 40, minus 40 is minus 40, not positive 40, minus 40. Below the axis the curve will be like this. Shear force curve will be like this. In this region the curve should be like this, from 21.6 to 41.6. The curve should be like this. Okay, this is uh, this is linear, this is linear, this is quadratic, this will be cubic. You just draw the curve. This is how much? 40 kilometer meter, I think. This is minus 40 kilometer meter. Minus 40. Indicate this is 40. This is 40. Indicate with a cubic curve, like some cubic curve. We don't know how the curve exactly will be. Equation of the curve is cubic. I will write curve. Indicate it as cubic. This is quadratic. Last section. This is, assume that this is point D. This is point D, and this is this point. This point. Last point D. Next, uh, next segment, segment figure shows value and segment x greater than or equal to 246 less than or equal to 10. 246 sorry, less than or equal to 8. 246 less than or equal to 8. Figure A, B, there is a load 38.33, 10 kilonewton per meter to C interior is covered. This is point D. There is 40 kilonewton. There is 61.66 kilonewton. I have passed the section x6 like this. This is the section x4, x4. This is xx. This distance is x. For better understanding here, A, A, B, C, D, x. In the examination also, even if you take 40 minutes, you should be able to do it in 40 minutes in typical. One easy problem will be there, one derivation, one typical problem. That also is after solving this, it should not be difficult. Okay, this is 10 into 20, 10 into 2, this is 20, 20, this is 1, okay, and then this is 38.33, and this is 40, and the entire load off into B into H magnitude, which is equal to off into B is 20, B is 20, 20 into height is 2, which is equal to 20, is acting at the centroid. Centroid is here. This is 20. This is 2. And if I write, if this is 2, this distance will be 2h by 3. This distance is 2h by 3, isn't it? If this is centroid, this distance is 2h by 3, which is nothing but 2 into 2 by 3, which is equal to 4 by 3. Okay, this distance is 4 by 3. You can write it. This is 4 by 3. This is h by 3, 2 by 3. Therefore, 4 by 3 plus 2 by 3, which is equal to 6 by 3. Then you will get the original length 2. Okay. Therefore, this distance shall I write this as 4 by 3, 4 by 3, and then therefore this will be this will be this distance will be, I will write it here in the indicated blue purple color, x minus x minus the distance I'm talking about, x minus 2 plus 2 is 4. Okay, entire load will come into picture, right? Okay, okay. Uh, 2 plus 2 is 4, x minus 4 plus 4 by 3. So x minus this is 2, this is 2a to b, b to c, b to c is 2, 4, c to this is centroid, this is somewhere here, center is 4 by 3, this is equal to x minus 4 is 12, 16 by 3, 3 4 is 12, plus 2 x minus 16 by 3. Okay, now this is x minus 16, x minus 16, x minus 4 by 3, x minus, okay, okay, this is x minus 16 by 3. 16 x minus 16 3. Okay, this is correct. X minus this distance I want from here. This remaining is x minus 16 by 3. This is right. Okay, I can write F is equal to shear force, which is equal to summation of forces in vertical direction, which is equal to Ra is there is no force, minus 20 plus 38.33 minus 40 minus half into B into H, entire force will be come into picture, minus 20, or which is equal to minus 80 plus 38.33, which is equal to how much, can you tell me? F is equal to, have I done anything wrong? Minus 20 plus 38.33 minus 40, there is one more, 60 plus 61.60 plus 61.60. What is the magnitude? Plus 61.60. 60, 98, 99, 60, 70. How much you are getting? 20, 20 kilonewton. Moment. Have you understood about the moment? If the complete section comes into picture, then I would have been taken this like this. If the section passes here, I would have been taken that length into x minus 4 by 3. If the section passes away from that UDL or UL, then subtract the distance x minus 4 plus 4 by 3. Then the remaining distance is our moment arm x minus 16 by 3. This is the moment arm. Okay, moment is equal to summation of moment of xx, which is equal to, like that. This will bend the beam like this. Let me write, this is minus 20, minus 20 is w into x into x minus 1, minus 20 into x minus 1 plus 38.33 into x minus 2 minus 40 into x minus 4, and then this load CD, this load is also coming into picture. I forgot to write 61.66. Okay, this is bending the beam like this, which is positive, plus 61.66 into x minus 61.6 x minus 6. Okay, coming to UL. UL is, this is acting downwards, bending, therefore magnitude is minus 20, and then distance is x minus 16 by 3. This distance is x minus 16 by 3. 2 plus 4, 4 plus 4 by 3, because x minus into x minus 16 by 3. I write the equation once again. M at x is equal to minus 20 x minus 1 minus 20 x plus 38.33 x minus 2, 38.33 x minus 2 minus 40 x minus 4 minus 40 x minus 4, 61.66 x minus 6 plus 61.66 x minus 6 minus 20 x minus 16 by 3 minus 20 x minus 16 by 3. Okay, next. M at x is equal to, this is where I have passed the section, and the segment is 6 to 8. M at x is equal to 6, which is equal to minus 20 into 5 plus 38.33 into 6 minus 2 is 4 minus 40 into 2, this is 0 plus 0 minus 20 into 6 minus 16 by 3. Can you tell me this value? M at x is equal to 8, which is equal to minus 20 into 7 plus 38.33 into 6 minus 40 into 4 plus 61.66 into 2 minus 20 into 8 minus 16 by 3. Tell me the value. This should be 0. This should be what value? You check it over whether it's 0 or not. Tell me the values. At x is equal to 6. You should get the same value, 40 kilonewton meter. Because there is no moment, you should get the same value, 40 kilonewton. Tell me what you are getting. How much you are getting?
Minus 40.
Minus 40, absolutely right. That's, it should be at the same. See, minus 40 in a sense, what you have calculated at x is equal to this point, x is equal to 6. We have calculated at x is equal to 6, right? Minus 40, same value we should get. In case if there is a moment like this, then only it will change. M at x is equal to 8, you should get it as 0. Tell me the value. Since only x terms are involved here, this is constant. This is constant. Shear force will be linear. Shear force. This is 0. Shear force will be constant. This will be linear. 0. Are you getting it as 0? Minus 140 plus 38.36 minus 160.
0, sir.
0. Therefore, shear force diagram is constant 20 kilonewton. This is constant 20 kilonewton. We'll draw this. Shear force is positive 20. Since there is a point load, shear force suddenly jumps. This is positive 20 to point D, and there is minus 20 here. So it becomes 0. This is, if you get positive 20, at this there should be one more load, okay, which is acting in the reverse direction. If you take the suction here, this downward is negative, therefore it will come back to 0. Always it should come back to 0. Bending moment is constant, bending moment is linear. Bending moment is linear, which is minus 40 and 0. Minus 40 we got it here at x is equal to 6, and this is 0. Since this is constant, this has to be linear. 0, linear. Okay. Now by this you should be able to solve any type of problem. I'll solve 3 or 4 problems. By this, having this in your hand and their mind, it should not be difficult for you to solve any type of problem. Let me give one more two hints like this. This will be helpful for you. For example, this is A, this is B, C, say 10 kilometer meter, 2 meter. Now, if I am passing the section here itself, say assume that this is up to D and this is up to E, and there is one more point load. If I passing, I'm talking about section A, B, C. If I am passing section here itself, then this will be something like this: RA to B. This distance is X. Since I'm passing here, this distance is X. Therefore, UDL will be 10 into 2. This is, sorry, this I'm passing it here. This will be, this distance will be X minus 2. This distance will be X minus 2. And this will be your uh, 10 into 10 into X minus 2. 10 into X minus 2. And the section passes there itself. In case, as in the most of the cases, it will pass. Section has to pass on the UDL, that on the section, away from the section also. away from the section like this. In the section CD, this is RA, this is your this node BC, and this is section XX here. Then you can write, RA BC. Instead of BC, I'll be writing it as 10 into 2, which is equal to 20 kilonewton meter, which is acting at this distance is x, this distance is x, this is x, this distance will be, and this distance will be x minus 2. X minus 2 force into perpendicular distance. If I subtract 2 from here, sorry, x minus x, this is x minus, this is point B, x minus 2 plus 1, x minus 3. Right, this is 2, this is 1, 2 plus 1, x minus 2 plus 1, x minus 3. From here, this force into perpendicular distance, this will give the magnitude of bending moment. Keeping these two concepts in mind, you can solve any type of problem. Same for this UL also. UL either, if this is like this centroid, this is the centroid. From this end, if you are coming, this is at a distance of 2h by 3 and 3h by 3. If the UL is given like this, then sorry, same figure. The UL is given like this. Then this is the center. This distance will be h by 3, and then this distance will be 2h by 3. Keeping this in mind, also the entire load is said to be accumulated at the center. This is how to solve the problem. Okay, neither easy nor complex. Many concepts are involved. Okay, let's stop at this point. Any doubts if you have, you can ask me. This is 10 into x minus 2 into x minus 2 by 2. This is 20 into x minus 3, 20 into x minus 3. That's it. Any doubts? Dhruti, Mekala, Raghavendra, Rakesh. Any doubts? I'll be stopping at this.
No, sir.
I'll be stopping at this point. Another 3-4 problems I'll solve. That should be more than sufficient from the examination point of view. Also, you can learn this.